Alright, in this video we're going to go over number 1 from the chapter 2 review. So when we have a non-linear inequality, which is what we have here, this is not a graph of a line, this is a rational function. First thing we want to make sure is that this is sort of simplified to be one fraction, which it is, and that it's 0 on the other side, which again, it is. If there was like a 5 over here, I would have to move that over, then recombine into a one fraction, and then solve. But since I already have one fraction and 0 on the other side, I can do one of two things. I can either make a number line and test some points, or I can do a graph. I'm going to go through the graphing way to explain this because I think it's more helpful since in this chapter you're graphing some of these things as well. So in order to graph, the first thing I want to think about is my my domain. And so in this case, my domain is everything except -6, because -6 would make this denominator 0, and that's not okay. And I want to think about, okay, now that I know -6 is not in the domain, I need to know, is that then a is that a whole or a vertical asymptote? And since -6 does not make the numerator 0, also, it's a vertical asymptote. Here's -6. We'll give a vertical asymptote there. Now the vertical asymptote is super important because my graph can jump from one side of the x-axis to the other on opposite sides of the vertical asymptote. The other place that we can do that is at an x-intercept. And an x-intercept is a place where the numerator is 0, but not the denominator. So I need to figure that out. So to find those x-intercepts, I'm going to factor the numerator. And in this case, it's x minus 2 squared. And I'll just keep that x plus 6 in the denominator. So I have an x-intercept at positive 2. Now that's another place that my graph could cross the x-axis. But in this case, I know that it won't actually cross the x-axis. Because my factor here has a multiplicity of 2, which is even, so we're just going to touch the x-axis and then turn around. And so it could either look like this or be down here. So over on the right-hand side, we're either going to be always above the x-axis or always below, and then touching at just that one point. So I need to figure out which one, and I could absolutely just test points on either side of this vertical asymptote and see what happens. I'm going to go ahead and just figure out the end behavior, and again, the primary reason for me doing that is because I'm kind of reviewing how to draw the graph, which you'll have to do later in the review and on the test as well. To find the end behavior, the most logical way to do it is to actually do the division. So do x plus 6, divide that into the x squared minus 4x. There are some shortcuts for sure, but this is the way that I think makes the most sense in terms of finding the end behavior. It's not a shortcut, but it makes sense. So if I do my division here, I'm going to have an x, and then I'm going to multiply, and then subtract. So that gives me a negative 10x. Nothing to combine with the 4, so that just comes right on down. Keep going. So then that's minus 10. And then I get negative 10x minus 60. Subtract. And then that is 64. Now, that 64 has a lower power of x than this first term out here. So I know I'm done. And so the 64 is my remainder. So I write this as plus 64 over x plus 6. And now what's so important is that this expression here is identical to this expression here. It's just a different way of writing it. And when we're talking about end behavior, we're talking about x getting very, very large. And when x gets very large, 64 divided by 1,000,006,000 is very, very small. So this fraction has less and less and less of an impact on my graph as I go out to the right or the left. Now, when x is small, let's say x is 0, now I have 64 divided by 6, which is a little more than 10. That's having a large effect on my graph. That's really going to change what my graph looks like. But when x is big, this has almost no effect on my graph. So this is my end behavior. On the ends of the graph, this fraction has very little effect. So this is the end behavior. And so I'll just draw a rough sketch of that as the end behavior. Something like that. Now, as I actually graph, I've got to follow this vertical asymptote and this end behavior over here on the left-hand side. I could go up here, but that would cause me to cross the x-axis, which I know I cannot. So my graph must be down here. Now over here, on the other side of the vertical asymptote, again, I could do that same thing, but then that's going to make me cross the x-axis somewhere over here. Now I could cross maybe here because I know I can cross that x-axis here, but remember, so my first thought might be follow, cross, follow, but remember this has a multiplicity of 2, so it can't actually cross. So in order to follow this end behavior, I have to always be above the x-axis here. And so now I just look at the graph and I say, okay, my question is, where are the outputs of this rational expression more than or equal to 0? Well, everywhere over here. So anywhere that x is greater than -6, which is this one. All right, that's number 1.